What is the solubility of MgCO₃ in a solution that contains 0.060 molar of Mg2 plus ions? So the Ksp of magnesium carbonate is 3.5 times 10 to the negative 3. So since this is a solubility equilibrium problem, the first thing you need to do is to write the dissociation of magnesium carbonate. So that's a solid, and it will dissociate into its ions. We have Mg2 plus and carbonate anion. That's also aqueous. So now that we have the equilibrium reaction, we now construct our ICE table. So we know that in constructing the ICE table, only gases and aqueous species are included. Solids and liquids are not included. So MgCO₃ will not be included in the ICE table, so we focus on the products. So according to the problem, the initial concentration of magnesium 2 plus is 0.060 molar. And for CO3 2 minus, that's 0. So for change, or C, since these are products, we put plus X for magnesium 2 plus and plus X for carbonate. So for equilibrium, that's 0.060 plus X for magnesium 2 plus and X for carbonate. After doing the ICE table, we need to write our Ksp expression. So we know that Ksp is products divided by reactants, but take note again, you only include gaseous and aqueous species. Solids and liquids are not included in Ksp. So in this case, our products are Mg2 plus and CO3 2 minus. Again, since the reactant here is a solid, so we don't include that in the Ksp. So this is our Ksp expression. Now it's time to substitute the values. The Ksp given is 3.5 times 10 to the negative 8. That's equal to Mg2 plus is 0.060 plus X. CO3 2 minus is X. Now, we are taught the approximation method to solve this problem easily. So how does the approximation method work? So as you can see, the given Ksp is a very small number. So 3.5 times 10 to the negative 8 is a very small number. So that means the X that we are going to solve is also a very small number. So we can let this X to be equal to 0, or in other words, it's negligible. So if we do that, our equation now becomes 3.5 times 10 to the negative 8 is equal to 0.060 times X. So to solve for X, you divide both sides of the equation by 0.060. So 0.060 cancels on the right side. So that means X is equal to 3.5 times 10 to the negative 8 divided by 0.060. And that's approximately equal to 5.83 times 10 to the negative 7. And since we are talking about solubility, the unit is molar. So the answer to this question is 5.83 times 10 to the negative 7 molar.